Hi, in this video I'm going to walk you through the Spring Boot integration tutorial. All the Spring Boot material is in this URL, styles light Spring Boot in the document site. We're going to walk through this tutorial. The tutorial is based on the Spring Boot Servlet implementation because Spring Boot 2.0 has two different style programming. One is based on embedded servlet container. The other one is embedded HTTP core to support async I/O. It's called the WebFlux. Because a lot of our customers are asking for how we can integrate Lifeforge middleware handlers with existing Spring Boot applications. Most of them are using Spring Boot Servlet. So this tutorial is based on the Servlet. So the first is we basically create a new application using this Spring start.spring.io, and we select Maven as a project, Java as language, and Spring 2.13 is the version. And you can select your group and your artifact. And for us, we select web as the dependency. So once you got the project started, the first thing to do is to switch from the default Tomcat to Undertow, because Lifeforge is based on Undertow HTTP core. So we need to inject our handlers into the underlying Undertow core. So first, let's walk through this light Spring Boot repository. Here we have this light config, which is the module we created called Spring Servlet. When you are trying to integrate Lifeforge components or middleware handlers with existing Spring Boot applications, you need to include this Spring Servlet into your Spring Boot application. Within this, you have this configuration called light config. It's annotated as a configuration. This is Spring annotation. And here, you can see we basically create a new factory, and within this factory we override the customize method. When we initialize the handler, this is a Lifeforge handler component, and after that we basically pass the handler into the orchestration handler of Lifeforge. So basically it works this way. Whenever the request coming in the request response chain, it first goes through the orchestration handler. Orchestration handler basically is a middleware handler chain. It goes through a list of middleware handlers within Lifeforge, and then we pass the control to the Spring Boot handler, which is the initial Servlet handler. This handler will basically pass the control back to the Servlet Spring Boot controller. So this is a very small component. You just include this component with the external configuration. The Spring Boot application can utilize Lifeforge handlers. Now let's take a look at the generate project. We call this project Servlet. The source code can be found in the light example Forge Spring Boot /Servlet. So you can check the source code over there, the final version. After we generate the project, the first thing we did actually is updating this pom.xml. Within the pom.xml, we add this section, exclusion, to exclude Spring Boot starter Tomcat from the Spring Boot starter web. And also we add this new dependency called the Spring Boot starter undertow. With this update, the underlying embedded servlet container will be switched from Tomcat to undertow. Also, we made a change like here to have Lifeforge version 1532 property defined here. Also, we add this dependency, com network spring servlet. The version is the Lifeforge version. This is the module we just walked through. With this module embedded into the pom.xml dependency, all the middleware handlers will be part of the transitive dependencies. So you don't need to specify any other dependencies from Lifeforge. Let's walk through the application, the generated application. After the application is generated, you should have this demo API application. So we made some update for the demo application. So first, we add this section, annotation, component scan, and specify the package com network nt. If your application is in some other package, this package is different, you probably need to have two different packages there. Because our application, we are using com network nt. Also, our configuration that light config is using the same package, com network nt. So we only specify one package here at the component scan. This component scan will basically find all the components within this package, as well as the one we just included, the Spring Servlet component. Other than this annotation, everything is the same, like the normal Spring Boot application. The next, we are going to update the specification. Lifeforge is a framework like encourages design-driven approach. So in most cases, we design the specification first, and we generate the application based on the specification. Also, we load the specification during the runtime so that the schema validation as well as OAuth scope validation can be done through the specification. So the specification, now we just copy this all the configuration from the Lifeforge configuration into this folder. It's under the resource config folder. And the specification is part of it. This is the spec file, the specification file. We made some change in the specification file so that this is based on the existing patch store for OpenAPI 3.0 specification. It's a demo specification from OpenAPI world. We made some change so we can have this prefix light or prefix spring. So the same endpoint before, we basically add the spring prefix or light prefix so that we can implement both in the same Spring Boot application. One set endpoint is implemented using the Lifeforge handlers, the business handlers. The other set endpoint is using Spring controller. But all the endpoint actually goes through the middleware handler provided by Lifeforge for some cross-cutting concerns. If you look at the functionality, we have list all paths, and we have a post to create a new path, and we have a get for one path by the path ID, and we have delete the path by the ID. So the specification is very simple. One thing I want to mention is this, like all the configuration actually is copied from one directory from the example application called PyStore example application. So you can see this application. You can find the application from NetRT organization. It's in the light example 4J. Okay, here we go. Within light example 4J, you have this REST and OpenAPI and PyStore. So if you go to the PyStore application, you can see all the examples in this folder. Yeah, that's exactly examples we copied over. We copy every configuration file into that newly created Spring Boot application in the same SRC main resources config folder. This is internalized within the application, and later on you can externalize this to a outside separate directory. And if your application is deployed inside the container, you can specify the volume so that the container can find the configuration files. You change configuration, you don't need to change the containerized application. So this is where the configuration coming from. Let's go back to the application again. So we walked through the specification already. We made some change like from the existing PyStore application. Let's go back to this application. And the next we want to make some change is the handler.yaml. The handler.yaml is defining the middleware handler chain. So you can see we define all the middleware handlers here. Those are the Java handler instances or handler class. You can give them an alias, and some of them we don't have alias at all. We're just using existing. This defines all the classes, so that's load into memory, and this defines the chain. So you can see the chain for Left4j implementations. We pass through the chains exception, matrix, traceability, correlation, specification, security, body parser, audit handler, sanitizer, as well as validator. So those middleware handler will be passed through before you reach the final business handler. For Spring Boot, it's very similar, the default handler chain, but we basically comment out the body parser. So we don't parse the body, so that Spring Boot application can still, like your controller can still consume the body stream. If we parse it, it won't be available anymore. And you can see we define all the paths here, like a light / path is get method, and the execution goes through the default light handler chain, and then call this handler pet get handler. And if it's a Spring Boot for the similar endpoint, it basically call this default Spring Boot middleware handler. That Servlet Spring Servlet config will automatically, once you finish this handler chain, will automatically pass this control back to Spring Boot. Similarly, you have post, and you have a get request for individual pad, as well as you have this delete. Others like health check, server info, specification, those are standard for Left4j. It works the same way. So this is how we config each individual endpoint. Now, let's take a look at the Lifeforge handlers. The Lifeforge handlers basically are copied over from the pet store application in the same package, so we don't change anything. If you look at the implementation, it's very simple implementation. Basically, you implement this as a light HTTP handler. It's a business handler, and there's only one method. You handle the request. The passing exchange is undertow exchange. Once you get this, you basically create a response with this value, and you have header content type is application/JSON with this list of JSON string as a response. For delete is very similar. You just it's just like it is generated from the specification with the like code gen. So there is no real business logic. And the get handler by ID is just like you return one object. And the post, you basically post whenever you got the is returning the post object as well. So this is the implementation from Lifeforge. And if you look at this is the implementation. We're going to implement some controllers for Spring Boot. So the first list the paths controller. So you can see we have REST controller, and the mapping is /spring /paths, and we return similar list of objects. And path ID, this is a create path controller. This is for the post request, Spring paths, and the post request, and basically return the body, request body back as a response. And we have this path ID controller. So here we have one controller, you have two different mappings. One is get a request. You have ID pass in, you get one object back. This is a delete mapping, and you delete this particular path by this path ID. So this is a very simple implementation. It's just a demo implementation. Now let's start the application so that we can have some test. We're gonna start the application within this IDE so that we can test from command line. You can start with Maven command or just a java-jar as well. When you start this from IDE, you just do the run. Okay, now you can see we have the application up running. Let's open the terminal so that we can test the application. So first, let's hit the Lifeforge endpoint. You can see we got a result back, two objects in the list. And from the log file, you can see we got the middleware handlers are working. Like say we only output the audit handler. You have this audit entry like shows up in the log. Now let's hit Spring Boot endpoint for the same endpoint. You can see we got exactly the same result, and you can see here. This is the audit for the Lifeforge, and actually this is the audit for the Spring Boot application. And you can see it's undertow Servlet, dispatcher Servlet. So this is Spring Boot. That meaning the Spring Boot endpoint is utilizing the middleware handler of Lifeforge to address core cutting concerns like audit. Now let's try another command with a query parameter called limit equal to 10. You can see we are using Left4j endpoint with the limit equal to 10. If we use Spring Boot, it will be the same. But actually, we are not using this parameter anyway inside the application because the application returns exactly the same thing. However, this limit is defined in the specification. Says, okay, the limit is the integer. Now let's try to change the limit to something like ABC. It's not integer anymore. Let's see what happens. So if we do that, you can see we got a validation error. This validation is done by the Left4j based on the specification, because specification defines the limit is integer, but if we pass in ABC, of course we get error. The endpoint is Left4j endpoint. Let's try the Spring Boot endpoint. You can see we use Spring Boot endpoint, we got exactly the same error. So basically it means this request validator of Left4j is working for both Spring Boot as well as the Left4j business handlers. Now let's try some other endpoint. Let's say we try to get a single pad. Always the Spring Boot endpoint. They should return exactly the same thing. Now let's create a new pad using the post request. So this is the command for post request. This is for Left4j endpoint. You basically pass in the content type is application JSON, and the body is just like a JSON object. It returns this object back. And let's try Spring Boot endpoint. So this is Spring endpoint. It should have exactly the same result. For delete, the same. Like it's just like yeah. Now it's delete. As you can see, we are using delete as a action, and we have this key equal to 1 in the header, and here you have this 1 in the header as well. This header is defined in the specification. It needs this header. If without this header, it will get error. We'll try that later on. So now you can see we got the result back. For Spring Boot, you should have the same result. Okay. Now let's try something like remove this header. Yeah, let's just go back. This is Spring Boot command. We remove the header. You can see validator request parameter header missing. This is the error you got from the Left4j validator. So that meaning we are basically using the specification to do the validations. Now, let's shut down this application and start and enable the security. If you look at the application, you can see we have a OpenAPI security.yaml. Within this file, right after that code gen scaffolding the application. This enable verify GWT is false. So you want to enable that, you can change this to true and save this file and restart the application. Now we'll have the application started again. Let's go back to this terminal and try some of the command we used before. Let's say this. You'll see we got a missing auth token. No authorization header or token is not bearer type. So basically, we enable the security. It requires you to go to our server to get a valid token, to put the token into the header in order to access your service. So this is a security feature. And that token needs to contain exact scope described in your specification. So we are using this light endpoint. Let's say we try the Spring endpoint, to say the similar endpoint. You should have the same error message because the Left4j middleware handler is working at a very low level. It covers both Spring and the Left4j implementations. Now, let's see. We're gonna basically we're gonna copy a JWT token from the pet store application tutorial, and we're gonna run this command with a long-lived token. So you can see we copy this command. This command has a token. Let's make this a little bit bigger. Let's run it again. Just walk through this curl command. We have header authorization bearer, and this is a token, the JWT token, and then we hit this endpoint. When you do this, you get the result back. And you can see this is Spring endpoint. So that meaning whenever you have the right token, your service is accessible. So this concludes the walkthrough for this tutorial application. If you have any questions, you can go through the documentation for the tutorial. The documentation the entry for the documentation is here, API style, Spring Boot integration. From here, you have all the information about how you get started with Spring Boot application. If you have any other question regarding to Left4j, you can access the Left4j community to find the contact information. If you have any question, we would like to help. Thank you for your time. Bye.